Hi, welcome back once again to my page. I want to solve the second question on the board to improve on the knowledge of the first one, which I have solved. It's already on my page. Kindly check it out because I explained the basics of inequalities in two variables involving graph. That's where you get the basic knowledge to solve this second question. But for the second question, I'll go straight to the solution. Alright, so the first thing you do is to change the inequalities to equation 2x plus 3y equal to 6, and then we produce a table for it, x and y. The second one, y minus 2x equal to 2. We also produce a table for it. Okay, then for the last one, y greater than or equal to 0. We are not producing any value for it because we have just y greater than or equal to 0, no value for x. Then we solve. With the knowledge of y and x intercepts, we simplify. When x is equal to 0, y will have a value. Put 0 for x here. 2 times 0 will give me 0. I will have 3y equal to 6. Divide both sides by 3. If 3 divides 6, I will have y to be equal to 2. Then also say that y is equal to 0. If I put 0 here, 3 times 0 is 0. This is gone. Use 2 and divide both sides. So 2 divided 6 will give x to be equal to 3. We have gotten this value. So put 0, 2, 3, 0. Move over to this one. The same thing. If x is 0, that means 2 times 0, this is gone. Y is equal to 2. Y is equal to 2. Then in turn, if y is 0, this is 0. Use minus 2 and divide both sides. My x becomes minus 1. That means I have 0, 2 and minus 1, 0. For the third one, we are going to be plotting it direct on a Cartesian plane. So let's sketch a Cartesian plane. I'll use 1 unit to represent 2 cm since the highest value I have is 3. Okay, so this is 1, 2 and 3, minus 1, minus 2 and minus 3. Here is y-axis and here is x-axis. 1, 2 and 3, minus 1, minus 2, minus 3. Okay, we plot. When x is 0, y is 2. 0 is at the origin. So when x is 0, y is 2. I'll make an asterisk here. When y is 0, x is 3. y 0, x 3. Okay? Join the 2 points. Dotted lines. Extend it a little. We use dotted lines because we have less than. When you have less than, you use dotted. For the second one, I have 0 for x and 2 for y. 0 for x, 2 for y at the same point. And when I have 0 for y, I have negative 1. 0 for y, negative 1 for x at this point. I will use a thick continuous line because I have less than or equal to. Okay? Alright, don't forget here is 2x plus 3y less than 6. And this is y minus 2x less than or equal to 2. And for the final one, y greater than or equal to 0. That means we are shading directly on the x-axis. If I have x greater than or equal to 0, that means I am shading the y-axis. So for this one, I will shade the x-axis. So let us shade. The first one is less than. Less than, we shade below the graph. So if I should shade, I will be shading under here, okay? And for the second one, I also have less than or equal to. I'll be shading below it, which is here, all right? And for the last one, greater than 0, above the line, I will shade above the line, The next thing you do is to check out for the region produced by the 3 inequality lines, which is inside here. We now shade it well. it well. The side produced by the shading, where you have common to this all the shadings. Alright, so this is my region produced by the three inequalities, which we call the feasible region. Okay, so this is the graph of this second inequalities. Thanks for coming on board. For solid knowledge on graph of inequalities in two variables, check the previous video I dropped. I explained every concept there. Thanks a lot. Don't forget to like my videos and also share to your friends. You will have a learner in your downline that will benefit from this video. Thanks so much.